That's it. Yeah. Thank you.
And finally, we've got Sonalika. I don't know. There we are. Great. Thank you. Just, you just need that. Cool. Awesome.
Should ask, are you able to see me? Yeah. Oh. Well, good evening all. Some. Sure. Okay. So, how many of you have, yes, this one, better? Sure. Let's start with a question now. How many of you have migrated from different countries to here? Lots? Well, this presentation is not for you. This is regarding some application, monolith to microservices migration. Let's go to another story now. How many of you have hosted parties at home? Yes. So think of a scenario where you have to host one family or one friend. It's easy, right? You just have to prepare some food, do some talking or decorations, that's all. That's a monolith application, we call it. And how many of you, again, think another scenario where you have to host 50 families or like that, along with their, 50 families or 100 families. That's a microservice kind of architecture. So this is a beautiful analogy. I thought it will be interesting. So monolith to microservice. When any application starts, when a domain or a company starts, it is in a single unit, and that is monolith. When the company scales for different reasons, maybe for customer acquisition or going to different countries, it has to scale, and that is microservices. Now, let's get deeper. What is microservices architecture? Well, it's many smaller applications which makes the bigger application, right? So it's a collection of small, loosely coupled services. And they are independently scalable. I mean, the individual applications are scalable by themselves. And, one good example is Netflix, which is around 300 million subscribers, and it is projected to rise in a drastic level every year. It was an early adapter of microservices architecture. And they did it by microservices architecture only. So it's really meaningful for scaling any business. And now there is another advantage of tech stack flexibility. So before, unlike monolith, if you start with Java or you start with .NET, you have to continue that. But with this microservices, you can leverage different technologies because every service is an application in its own. There is resilience advantage as well. No services is dependent on any other service. If that's the reason nowadays you will see in web applications, if one particular functionality is not working, still the whole application does not go down. It still works. That is because of resiliency. What is two pizza teams? And you know what is two pizza teams? Who coined it? It was Jeff Bezos. He says team will have that many number of people, the number of people in that team will be no more than how many can be fed by 2 large pizzas. So if 2 large pizzas is eaten by 3 people, then that should be the number of people in the teams. So that was an adoption. And it works, believe me. Sounds good, microservices, we are migrating, but it has its own complexities. One of the main complexities is data consistency. There are different databases which I will talk later in my presentation. Each application in its own has its own database. So when a transaction goes through transactions again is any transaction. You create an order, you create an invoice. It goes through many databases, unlike Monolith, which has a single database. So to keep up the consistency is really difficult. And we have different mechanisms to do that, but it comes with their own complexity as well. We really need, because these are different services, there is more network needed. They talk to each other, the services talk to each other with HTTP or the internet. So there is requirement of service communication. Again, we have cloud providers. They provide a lot of technicalities like VPC, subnet, peering rules, but they have their own complexity again. It takes time to manage all these things. Again, similar reasons, monitoring is difficult. It's not difficult, but it takes time, and we have to have extra setup again there. Now, we understood what are the advantages, what are the disadvantages, but we have to start with migration. We have to consider something. There is DDD, we are here, right? But this is different DDD. This is domain-driven design. That means you understand what is the domain of the business, of the company. You start with them. Those are the main pain points. You figure out what are the pain points, take them as separate applications. That is how it is started. It starts migration. The migration starts. And who does that? People. That's my second point. And we should not forget about the people aspects. So when you start migrating, there is a team who has to look after the monolith, the previous application as well, right? So and there will be different teams who will be working in the new migration project. So this is really a people aspect of it, where the people who work in the legacy application are sad. That's why it shows happy face, sad face. So the workaround around this is also there, where you switch the teams. You make them work in you switch the teams. They will work in all kind of applications, the legacy and the new one. So keep them happy. So this is really a major thing I have seen in my projects when I was doing. So we used to keep an eye on this as well. Now, this is a very important factor. You have to decide. It depends on the business or the company. You have to go with asynchronous or service-to-service communication. And service-to-service really works, but there are many, because it depends on the network. Every time, direct communication cannot be provided. So there are event-driven architectures, which we call asynchronous. There are tools around it. Nowadays, market leader is Kafka, I would say. There is Amazon SNS, SQS as well. I myself have applied Kafka in different projects, and it really works well. So yeah, these are some considerations, important considerations. There are many more as well. See, in the beginning, I told you we'll have a party. So it's ice cream and Legos for games. Not the nuclear one, please. So these are some of the strategies we can follow, and none of them is good or better or worse. It really depends on what the company is doing. So there can be cases where ice cream scooping. So what happens is you have a monolith, you scoop out some functionalities, take it away, and that will be your new service application. So just scooping it out altogether from the previous one. So that is ice cream scoop. But the Lego one is, you have the application, but you make it modular. When you make it modular, the modularity can be used. So the complexity of the whole application increases, but yes, you can use the modular things. So this is the Lego pattern, but it is useful in some cases because the legacy system still works for the company. We have to keep it intact. This is one of the, nuclear is one of a good and mostly favorable also in many companies now. This is a complete and rapid decomposition because you are not taking care of the previous one, like it's a completely rapid decomposition. Phase by phase you will do in a controlled demolition kind of. It's really good. This is a good strategy, but it really depends again what the company is, what is the time consideration of the company. In that way we think of it in the beginning itself, which strategy we have to apply. Don't have many pictures here, but this is a really important concept in microservices, and this is the most major part of it, database. So one database per service. So every application will have its own database. There is advantage to it. Polyglot persistence, that means because we have different databases now, we can have different kind of databases now. So suppose one of the database needs ACID properties, then we can go for SQL database. If we have base properties is okay, then we can go for MongoDB or like that, NoSQL databases. That's polyglot. Data consistency, we need to think about it. It's really great, very deep concept. And then data replication and sharding. This is mostly used for performance and fault tolerance. This is related to actually infrastructure of it, but yeah, important. Now, once the migration of an application starts done, we have these things very important: routing and versioning. There is an API gateway concept, which API gateway, what it does is it intercepts your user's requests and it routes it to correct microservices or services. There are a lot of important other things which API gateway can handle, but there is we consider it in the beginning to make it balanced. So we cannot give everything to API gateway to be done, but yes, API gateway can do many things. Mainly it is used for routing the requests. So this we take, and the market leaders are like Kong, APG, and like that. Different tools are there. There is, because now second point, service discovery. If the services are there, they need to be dynamically able to find each other. So in the table I have written some of the tools which the companies use. Mainly Netflix has started it. It started with Eureka. I think it's with Java and Spring Boot kind of. And then all these are just for us to know. But yes, there are a lot of, we need to again think which tool is better when we start migrating. There are API versioning strategies. And why do we have API versioning strategies? We can name it. The next version can be 2, 3. But yes, sometimes what happens, we don't want our user to get impacted by our version changes. So we have different strategies in which the URL does not change, but we can do it through header changes, query params changes, so users are not impacted. That's the reason API versioning strategies exist. There is traffic load balancing. This is a very important concept, although I have put it in the end, because there is lot of internet traffic and needs to be load balanced. These are again, down you can see the major data breaches over the last few years. I tried to pull some of the breaches from 2013, and there was lots of, I think 60-70 million was the fine one of the companies had to bear. So yeah, major data breaches. So central authentication, so for that, these are the points here are mainly some security related concepts. Authentication for any web application could be centralized, but authorization should be decentralized. That means the individual services should be able to control who is authorized to see them or work with them. But authentication should be centralized. That means user will have just one login. Then minimize shared libraries. This is another concept. There is defense in depth, which is the third concept here. That means every layer of the application should be secured. It can be the transport layer. It will be the any other layer, 3-4 layers. We have like 9 layers. So yeah, multi-level security is important. Service mesh, it's really another important thing. Mainly we go with Istio. This is a book. This is the book which I was reading, and for this PPT. If it hurts, do it more frequently and bring the pain forward. This is the most important concept. So that's why we do continuous deployment. We need the feedback quickly so that we can improve. So that's the concept of continuous delivery or deployment. There are tools in the market, Puppet, Chef, or Ansible. Myself, I have used 1 or 2 of these. But yes, transferable skills and automated configuration management is required. There is another thing, because we have a lot of servers, right, like the development, testing, production, UAT. We want to deploy the same artifact, that means the same code base which we have committed, to the same thing to different servers. So it makes sense to have a single artifact, but the configurations will change in different servers. So we should have separate config, and practically we have separate repository for configurations, whereas separate repositories. There are 2 more things. Service to host mapping. This means every service, what this means is we need to understand how many services will go to how many VMs or where they will be deployed. So this is again a really infrastructure concept, but it needs to be taken care of because it finally leads to bottlenecks or performance of the application. Finally, we have Docker. It should have been in the beginning, but it's very important. Docker actually ships, and Kubernetes throws the orchestral party. So yes, this is the continuous deployment. I think I just gave the high-level summary of microservices, monolith to microservices migration. It's very vast. I just tried to keep the tools here. Happy migrating.
Thank you. Okay. Sorry, I'm taller.
Yes.
Regarding database in a microservices architecture, is it acceptable to replicate data across services, or should data only exist in a single place?
Sorry, the question is, it must be, regarding database, is it acceptable to replicate data across services? Replicate.
Yeah.
It is. For some read-only databases, we replicate it. Because during the migration process, we do need to replicate it. Because what happens is the database, when we break the monolith, we cannot do it in one go because the domain, the application is running, the company is making business out of the monolith itself. This is just a migration strategy which will come in future years. So we cannot break it, but we still need the databases in our microservices architecture. So we must do that. Yeah, that's my answer.
Awesome, cool. Regarding, microservices are in trend. However, when do you think we will need to stick to monolith, even though our customer base grows?
It really depends. If you do not have time, but eventually if your customer base is growing, they will have performance, performance will degrade in the application. If you are able to sustain that, yes, go with monolith. If you are not, then please migrate. Yes.
Yeah. If you had to choose between a world where everything is microservice or monolith, which one would you choose and why? I think you just answered that.
Okay.
Monolith or microservices?
Both.
There you
Both.
go.
Yes,
Not
both.
committal.
Do not start with microservices.
Yeah.
Start with monolith. Then you know the pain points, which part of the business is doing great. Then you can make microservices. So that is the starting point I told.
Awesome.
Find the pain points.
I like
Yeah.
that. How do you deal with the increased dependencies and network latency when migrating to microservices and scale up?
You have to go with, I mean, it's go with the tools given by cloud providers. They have amazing tools, already proven one. Don't try to reinvent the wheel here. Just use those. And they have a lot of services. Even I don't know everything, but yes, there are. And this is a main thing, main consideration as well. So pick one from any cloud provider.
Yeah.
And yes.
Awesome. That's all the questions we have here. Anything from the room? Nope. Awesome. Thank you.
Thank you.
Awesome. Where's the little adapter? Ah, there it is. Cool.
Yeah, it is. I will take my charge.
Oh yeah, cool. Please do. Thanks everybody. That is our last talk for the evening. I'm going to quickly flash up these slides so that if anyone would like to sign up and be a speaker at a future event, they can absolutely scan my QR code again. Please let me multitask for a moment. The next time we're going to be getting together is in September. As I say, we don't quite have a date yet. We tend to try and do the second Wednesday of the month, so hopefully that Wednesday in September. But if you would like to be a speaker, please, QR code is right here. I saw some people scanning it earlier, so I'm very excited to see what new talks pop up in that spreadsheet. But as you can see, we're a very friendly crowd, so it's a great place to come. Thank you again to our speakers. Thank you again to Mantel Group for having us. Thanks. Good night. So I'm going to leave it there, and I'm going to.
Yeah.